Hello everyone, let's solve this for Bode plot. The given question is g of s into h of s is equal to k into s square divided by 1 plus 0.2 into s into 1 plus 0.02 into s. So the question here is determine the value of k for the gain crossover frequency of 5 radians per second. The value of k is unknown. The question is already in 1 plus s into t form. Now let's find the magnitude at origin. We can observe that at origin we have k into s square. So 20 log of k into s square, we can also write it as 20 log k plus 20 log of s square. So replacing s with j omega and taking the magnitude, that is omega square. So now we know the value of omega at origin, that is 0.1. So 20 log of 0.1 square will be minus 40 decibel. So we know the second value, but we do not know the value of 20 log k. So now let's take an example. This is the magnitude plot without the value of k, and the magnitude at origin is plus 40 decibel. It means that this is the point at which the graph is going to start. Now let us assume the second case with the value of k, that is 20 log k is equal to 10 decibel. So there is a shift of 10 decibel in the magnitude at origin. So before it was 40, now it is going to be 50 decibel. So it means that the graph has just a shift of 20 log k. Considering this as a basic, let us do the problem further. Now let's find out the corner frequency of each of the poles and zeros in the equation. So first, coming to the 0 at origin, we have s square, and then simple pole, that is 1 divided by 1 plus 0.2 s, that is t1 is equal to 0.2. Omega c1 is inversely proportional to t1, which is nothing but 5 radians per second. And the second simple pole is 1 divided by 1 plus 0.02 s. The T2 value is 0.02. Hence, omega C2 value will be equal to 50 radians per second. Now let's find out the slope of zeros and poles. Taking this equation, we can see that there is first 0, that is s square. So as it is square, 2 times we need to consider the slope. So in the numerator, the slope is plus 20 decibel. So 2 times becomes plus 40 decibel. So the resultant slope also will remain plus 40 because this is the starting 0. Next we have 1 divided by 1 plus 0.2 s, a simple pole. We have already calculated the corner frequency, that is 5. As it is a pole, slope will be minus 20 decibel per decade. So already we had plus 40 decibel per decade. Now minus 20 decibel per decade will get added up. So totally the resultant will be plus 20 decibel per decade. Next pole is 1 divided by 1 plus 0.02 s. The corner frequency is 50. The slope will remain minus 20 decibel. So the total will be plus 20 minus 20, which becomes 0 decibel per decade. Next is phase plot analysis. Replacing the s value with j omega in the equation, it gives g of j omega into h of j omega is equal to k into j omega whole square divided by 1 plus 0.2 j omega into 1 plus 0.02 j omega. Now finding the angle of this equation, converting this to polar form, we get it as k at an angle 0, and let me assume that the value of this in polar form is r1 at an angle theta 1, and here r2 at an angle theta 2, and this to be r3 at an angle theta 3. So the magnitudes get multiplied and divided by, so it becomes k r1 divided by r2 r3. The angles get added up, that is 0 plus theta 1, and the denominator term shift to numerator, angle becomes minus theta 2 and minus theta 3. So now taking the angles, that is of g of j omega and h of j omega, the value of j omega whole square is j square into omega square, where j square value is minus 1. So it becomes minus omega square. So the angle of g of j omega into h of j omega becomes 0 plus tan inverse of the second term, that is 0 here, wherein the real term is 0 and imaginary term is minus omega square. So 0 divided by minus omega square, and next the value of theta 2 is minus tan inverse of 0.2 omega, and theta 3 is minus tan inverse of 0.02 omega. Now finding these angles with the different omega values, we get j omega square value is plus 180 degrees. So throughout it's going to remain constant, and then we have minus tan inverse of 0.2 into 0.1, which gives minus 1.14, and here minus tan inverse of 0.02 into 0.1 gives minus 0.11. The resultant angle will be plus 178.74, adding these three angles. Next is for 1 radians per second, finding the value of minus tan inverse of 0.2 into 1, which gives minus 11.3 degree, and minus tan inverse of 0.02 into 1 gives minus 1.14. The resultant adding these three angles will be plus 167.55 degree. Similarly, finding the rest three values with the resultant angle, we get 105.29 plus 29.46 and 0 degree. Now plotting the phase plot, we get at 0.1, that is plus 178.74. So 0.1 is here, marking with 178.74, and next is 1. So 1 is here with 167.55 degree, and next point is at 10, which is 105.29. Similarly, at 100 we are going to get it as plus 29.46. So now joining the curve, joining the points, we get this graph. Now drawing the magnitude plot without the value of k, that is neglecting the value of k as we do not know the value of k. So first is the 0, that is s square with plus 40 decibel slope. So now we will just consider that the starting point will be minus 40 decibel, that is the magnitude at origin, that is will neglect the value of k, and then draw plus 40 decibel decade until we reach the corner frequency 5. So once we reach the value 5, we need to draw a slope of line with plus 20 decibel per decade. So just drawing plus 20 decibel per decade until it reaches 50. So from 50 we are supposed to draw a 0 decibel line, that is without any slope. Now we can just observe that at 5 radians per second, as given in the question, at 5 radians per second, the value of the gain crossover frequency must be obtained. But we can see that there is a difference of almost 28 decibel value. So it means that the value of 20 log k must be 28 decibel, so that the graph shift towards x-axis at WGC, that is 5 radians per second. So now we'll calculate the value of k accordingly. 20 log k is equal to minus 28 decibel. So therefore the log k value will be equal to minus 28 decibel divided by 20, and then the value of k will be anti-log of the value obtained. Therefore the value of k will be equal to 0.04. Thank you for watching.